before going into chapter 4, we need to review trig ratios. Here is a right angle triangle with angles theta, the opposite, adjacent, and hypotenuse sides. Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. To remember these ratios, we can simply remember SOHCAHTOA. Today I'm going to be focusing on sine and cosine. This is the graph of sine x, and we're going to talk about the rate of change, also known as slope. So we know that the slope of a graph is equal to 0 at the minimum or maximums because there is no rise and there's no run. So here the rate of change would be 0, 0, 0, and 0. We also note that at the x-intercepts, it's either a maximum or minimum slope. So from negative pi over 2 to negative 3 pi over 2, the rate of change is decreasing. So it starts off here and then goes to 0. Now from negative 3 pi over 2 to negative pi, the slope is also decreasing. So we would go from here to here. And then we go 0, and so it would increase from negative pi to negative pi over 2. From negative pi over 2 to 0, it would also be increasing. So that would be there. And then from 0 to pi over 2, it's decreasing. And then from pi over 2 to pi, it's also decreasing. And then from pi to 3 pi over 2, it's increasing. And from 3 pi over 2 to 2 pi, it's also increasing. So if we draw this in, it will look similar to now we're going to do the same thing graph. With the cos graph. We know when the slope is equal to 0. Okay, and from negative 2 pi to negative 3 pi over 2, the rate of change is decreasing. So here. And then from negative 3 pi over 2 to negative pi, it's increasing. And from negative pi to negative pi over 2, it is also increasing. From negative pi to 0, pi over 2 to 0, it's decreasing. And from 0 to pi over 2, it's also decreasing. And then from pi over 2 to pi, it's increasing. And pi to 3 pi over 2 is also increasing. And then from 3 pi over 2 to 2 pi, it decreases back again. So then if we connect the dots here, sorry if it's not that great, the graph looks like a negative sine graph. So we can tell that both sine and cosine, the derivatives of those, also known as rate of change, are also sinusoidal functions. Identify the x values in the interval 0 to 2 pi, where the slope is 1, 0, 2, a local maximum, and 3, a local minimum. Now we note that the 0 slope occurs at the maximum and minimums of the graph. So we can tell that there is a minimum here, maximum here, and another minimum here. So wherever the blue is, that's the x value at which the slope is 0. So 0, pi, and 2 pi. Now for the local maximum, we know that the maximum or minimums of the slope occur at the x-intercepts. So for a local maximum, we can just go through all of them. Now, the slope at pi over 2, it increases and then it decreases. Now we know that if it increases to decreases, it's a local maximum. So pi over 2 is a local maximum. If we look at 3 pi over 2, it's decreasing and then increasing. So that's a minimum. So that would be green. So that's a minimum. And that's all in the thing. But there's also 0, 1, which is a local minimum too, because the slope decreases and then increases. So, local maximum occurs when x equals 3 pi over 2, and a local minimum occurs when x equals 0 and x equals 3. We need to find the slope of the tangent line to the graph of f of x equals 3 sine x at the point where x equals pi over 6. So the first thing we need to do is find the derivative of f of x. So f prime of x is equal to 3 cos x. After that, we need to plug in the x value into the derivative. So then f prime of pi over 6 equals 3 times cos pi over 6. So that would equal 3 times root 3 over 2. So that equals 3 over 2. So the slope of the tangent when x equals pi over 6 is 3 over 2. To find the derivative of sine, we can use the first principles that we learned from chapter 1. And we will also need to use the identity sine A plus B equals sine A cos B plus sine B cos A. To find the derivative, we find sine x plus h minus sine x over h. Using that same identity, we can see that limit as h approaches 0, sine x cos h plus cos x sine h minus sine x all over h. And then we can reduce that to sine x cos h minus 1 plus cos x sine h all over h. And then limit as h approaches 0, sine x cos h minus 1 over h plus cos x sine h over h. So I just divided this into two parts. Now the limit of as h approaches 0 for sine h over h is equal to 1, and the limit as h approaches 0 for cos h minus 1 all over h is equal to 0. If we plug that back into the equation, we get sine x times 0 plus cos x times 1, and that equals cos x. So the derivative of sine is cos x. So we know that the derivative of sine x is cos x. So there's an easier way to find the derivative of cosine rather than using the first principles. So y equals cos x. And we know using the difference identity that cos x equals sine pi over 2 minus x. So what we can do to find the derivative of this is use the chain rule. So for that, we would have to find the derivative of sine multiplied by the bracket, and then we would have to find the derivative of the bracket inside. So the derivative of sine is cos pi over 2 minus x, and then the derivative of the bracket is negative 1. So the derivative of sine x times negative 1, which equals negative sine x. So the derivative of cosine is negative sine x. Okay, so we're going to find the derivative of these two functions. Now for this function, we know that 3 is a constant, so we leave that there. And then the derivative of sine x is cos x. And then we just expand that, so it's 3 cos x. It's as simple as that. And now for this one, we would do the same thing. Y prime equals -5, which is a constant. And the derivative of cos x is negative sine x. And then we just expand this. Negative times negative is a positive. So the answer is 5 sine x. There are 2 more examples to find the derivative of, but then in these 2 examples, there's 2 parts to the equation. But we'll still do the same thing. So y prime equal to, the derivative of sine x is cos x, so we do cos x plus 2. Derivative of cos x is negative sine x, so negative sine x. And then we just expand it again, so it's cos x minus 2 sine x is the answer. Now do the same one for this, so y prime equals 4 times negative sine x minus, derivative of sine x is cos x. So then this just equals -4 sine x minus cos x.